morning again, guys. I had this video previously recorded till we ran into some technical glitches. So I'm just jumping right in to molecular or covalent bonding. The previous video had kind of everything else leading up to this point. So, common molecules that would have this type of bonding would be any of our non-metals, okay, so our hydrocarbons, water, carbon dioxide, anything like that, hydrogen chloride, anything at all, okay? So we're going to do a couple of the most common ones first, okay? So clearly hydrogen and oxygen are not metals, and they exist as a molecule with this type of bonding. So just like before, you set it up kind of symmetrically when you're doing your drawings. I think that's useful. You got to think back to your Lewis dot diagrams now and understand that hydrogen just has the one electron. Oxygen has an atomic number of 8, so it's got 2 and then 6. 1, 2, 3, 4, 5, 6. And what this type of bond actually is, it's a sharing of electrons, so there's no electrical imbalance action going on here. You're just going to have a couple of electrons that end up being shared between the individual atoms, okay? If you want to do it nice and neat, which of course we do, we can get rid of our x's altogether, and then every time we see a straight line in this type of chemistry, it represents a bond, and it represents 2 electrons being shared. Okay, so that's what our molecule of water would look like. And when we set up our molecular building lab, possibly at home, you guys will actually kind of put a few molecules together, but you wouldn't actually have the random electrons shown. So we would even skip that part in an actual lab building scenario. Okay, so that's our hydrogen and oxygen, otherwise known as water. If we want to throw in another common molecule here, carbon dioxide, same deal. Let's set it up symmetrically first. Carbon, oxygen, oxygen. Do our dot diagrams. Oxygen has our 6 electrons. Now I'm getting really lazy and just doing dots. Carbon has 6 electrons total, 2 in the first, leaving 4 in the second for the valence orbit for carbon. And then the final step would be to show some bonds by having 1 electron from each atom connected. That doesn't look real tidy. Let me fix this one up. So 2 bonds, 2 and oxygen. There we go. So now you can always check these molecules by counting electrons. And remember that each line or bond equals 2 electrons, right? So this carbon has access to 2, 4, 6, 8. 8 electrons completing its valence orbit. It's happy. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. It's happy, and same thing there. Okay? So those are the 2 I really wanted to cover with you guys, and I think I'll leave it at that for now. Okay? You have to practice a few of these. I'll send you some work on some different examples, basically some compounds that you can practice, and then maybe we'll take them up on the next video. Okay? As always, if you have questions or comments, please email me. That's the easiest for me. Or Instagram them. That might be the easiest for you. And we can continue our learning that way. Okay? Thanks, guys.